I want to show you a bunch of different problems that you thought are different. Nowadays, they're much more similar than you think. They might even be identical in some sense. And show you that deep learning and machine learning is changing the way we do these things. This gives us a lot of potential benefits, but some really new and interesting, unique challenges. I'll show you in the end how I think about those things now and how I think we should progress. Recently, both Google and Microsoft boasted that at least a significant part of their stack doesn't work in the traditional way anymore. It works directly with machine learning and NLP techniques. Pinterest and Facebook allow you to search with a query, which is an image, and you search a very large catalog of other images. At Home Depot, when you're looking at your shopping cart, you want to be recommended other items that you might need to purchase. All of these things we expect to work with machine learning. We expect them to be smarter. We expect them to do things that are accurate, right? And you might not think about those things as the same problem, but I want to convince you that really they are. I want to have a model that just tells me for every pair of items, what is the level of match? And then, at least theoretically, from that black box alone, I could build everything else. I can now build a search engine for text. I can build an image deduplication service. I can build a recommender engine. I can build all of these things. In fact, this goes much wider. All recommender engines, visual search, enterprise search, e-commerce, online advertising, online fraud, facial recognition, online dating, online recruiting. Those are huge areas where the main problem they're trying to solve is of this form. And there is a very simple unified model that actually achieves incredibly good results. You can think about it as a vector embedding type technique. We see that neural nets are actually taking it to the next level, where you can embed things into vectors, have finary scoring, and actually train the whole thing end to end. This gives significant boosts. So why is everybody just using that and be done with it? If it's so simple, then why don't we just do that? Companies just don't have the right mechanism. If you want to launch an actual product, you have to prepare data and train models. And you have to have a serving engine that actually is able to, in real time, get a query and give you back results. And this serving engine needs to be robust and have good performance and not cost too much and be able to monitor and manage experimentations and so on. If you want to solve this in a way that works for your application, you really have to figure out all these things, and you have to build a very complex, multi-staged process, a multi-stage system, and each one of those needs its own data pipelines, its own optimization, its own monitoring, its own teams actually sustaining it. So this is a part of the AI or machine learning transformation companies are going through. At HyperCube, we're trying to think about how to do this in a unified way. What can we do to take this unified model of recommender or retrieval, a collection of items and queries, and create some magical hyperindex? Queries to just hit that index and you get the top scoring items, right? So now you just hit it with an image and get the most similar 10 other images, or hit it with a shopping cart and you want to get the most relevant items. With HyperCube, those things that we talked about, that actually are possible. On our stack, this is literally all the code that you need. It stands up a fully operational semantic search index on Wikipedia. Recently, we started working with Home Depot, where they do a shopping cart recommendation, where they take the user and the shopping cart and they do the top matches based on their model. They worked very hard on, it's their secret sauce. For them, getting to production with HyperCube is easier because they don't need to build out all those mechanisms. They just have the model that they want and they just serve it in production. With their new models, they're able to give results that are tested, that tests better when they actually present them to shoppers or present them to human judges. They would say these are actually better recommendations. So the take-home message really is that deep learning is unifying retrieval in some basic way. So we know that the best results are achievable within this model, but for the scientific and technology community, this actually gives rise to very hard and sometimes almost intractable problems. We at HyperCube and we as a community are working on it, and if you're excited about these kinds of problems, I'm very happy to hear from you.
Edo, Liberty.